Series of pictures from an Indian excavation from about 1400 AD. These are the bones from a burial site of an elderly, at the time, 50-year-old Indian woman who had broken her femur. And you can see the break here. It's pretty clear that there's one that's been badly damaged and the other that's not. They're a pair. And quite noticeably, there's the place where the break has occurred is a very large, thick, clumpy thing. And you'll also notice that the new bone is, the repaired bone is much shorter than the other one. This woman would have walked, if she walked at all afterwards, with a terrible limp because one leg was about 1.5 inches shorter than the other. And the reason this happens is because the muscles that hold together across the length of the bone, when it's broken, pull the bone ends across each other so they're no longer aligned and shorten it up. And then, of course, the same healing process goes on and it heals in that awkward position. Why is this not a problem for us now? Well, in fact, now we understand this and we avoid that. We understand that bone repair mechanisms will knit broken pieces together, right? If you know that if you're going to have a fracture, that the normal response to that will be to knit those pieces together. And the whole point of this is to then create an alignment before that happens by what's called reduction. It means reducing the fracture so that it is now aligned. And then keeping the position of those bones relatively stationary relative to each other, so that the healing process will end up restoring that original functional form. And as those of you who've broken something and had a cast know, mechanical stabilization is the key. You need to keep the mechanical alignment of bone in place for a long enough period of time that will heal and be relatively strong, and then you can take that cast or whatever's holding it together off. A fairly substantial amount of effort has been put into this in trying to find ways to provide this stabilization and reduction. There's a thing called external fixation. Some of you may have seen someone with an external fixator on. This is not uncommonly used if the injury has broken the skin. But you can also do what's called internal fixation, or an open reduction and internal fixation, where you do a surgical procedure. You see this in the middle, where you cut through the skin, you go down to the bone, and then you do something to hold that bone together. You might put a plate and some screws in. Or, as you see in the picture on the far right, you might do what's called an intramedullary nail. This is a long spike. It's about this long, depending upon how big the person is. And it's a big, long, it looks like a nail. And then what happens is you get the person in the right position, you reduce the fracture by putting traction on the leg to pull it apart like this so that the ends of the bone are now in line, and then you take a hammer and you drive the nail down through the hip from the top, as you see, all the way down and cross that and bridge that broken area, and then you put a little pin in the top to hold it there so it doesn't slide out. You can see why I'm an anesthesiologist. But in all these cases, the whole point of this is to allow the natural healing processes to make the bone and restore the bone to a position of function that it was in before. The issue is, what is that position and what is the function? We don't heal these things. The orthopedic surgeons do not heal bone. What they do is they rearrange bone and hold it in place for a long enough period of time that the natural processes that are resilient in bone will lead to a desirable result. Okay? This is a pretty important idea. In fact, physicians in general are not healers, although they're often described that way. The body is the healer. The physician creates, if they're lucky, a situation where the alignments and the functions are such that the healing can take place. But we depend upon that healing. And in fact, we know, for instance, if you have deficiencies of nutrition or other diseases, that the healing can be quite difficult. This idea about fixation is actually, and healing is actually rather old. It's for this reason that I commend to you the idea of bone as a model for, not as a model, as an archetype for resilience. And I hope that when people say to you in the future, well, what is this resilience thing? Tell me what resilience is. What does resilience mean? Or can you give me an example of resilience or resilience engineering? That the first example that will come to mind for you is bone. Because I think it's really beautiful. I think it's got a quality to it that is almost, dare I say, spiritual, that has so many of the aspects of resilience built into this one nice example that exploring it and understanding it is likely to prove to be very valuable for you in the future. Thank you very much for your kind attention.